This is the 5th video in the series about solving log equations and exponential equations. In this video, I'm going to cover example 7 and example 8. Starting with example 7, I see that we have a fraction on the left-hand side and I have the variable in the exponent. So not only do I have to get the variable out of the exponent, I also have to get the variable out of the denominator. So to do that, I'm going to cross multiply. And I'm going to cross multiply so that I get 400 equals 350 times 1 plus e to the negative x. But I'm not going to distribute that negative 350 because still I'm trying to isolate this x here. So if I distribute the 350, I'm just going to have to undistribute it later. So now I'm going to divide by 350 on both sides. So I get 400 over 350 equals 1 plus e to the negative x. That little flip-flop between those two values is pretty important to remember how that works. Basically, you cross multiply and then you divide, so those two parts sort of switch places. As I continue solving, I'm going to isolate by subtracting 1. So I have 400 over 350 minus 1 equals e to the negative x. In order to get my x out of the exponent, I'm now going to take the natural log of both sides. So natural log of 400 over 350 minus 1 equals natural log, which is base e, of e to the negative x. Remember, I didn't have to write this step. I could have just gone to this next step, which is natural log 400 over 350 minus 1 equals negative x. And then I multiply by a negative 1 on both sides. So I have negative natural log 400 over 350 minus 1 equals x. I would use my CAS to simplify this, so I have negative natural log of 1/7 equals x. That is my exact answer. And then I use my CAS again to simplify it to a rounded answer, and I get 1.946. And those are my two solutions. Go ahead and try part B on your own, and then when you're ready, restart the video and see if you got the answer right. So I'm going to flip-flop the base and the 7. So 119 over 7 equals e to the 6x minus 14. Remember, I was able to do that because I cross-multiplied by 7. And then I divided by 7 on both sides. So I just switched places. I just had those two terms switch places. Then I'm going to add 14 to both sides. So e to the 6x equals 119 over 7 plus 14. I need to get the x out of the exponent. So I take the natural log of both sides. When I take the natural log of the left-hand side, I just get 6x. When I take the natural log of the right-hand side, and actually if I do all this math, I realize that just equals 31. Then I can divide both sides by 6. So that would be your exact answer. And then you put it in your calculator. 0.572 is your rounded solution. All right, as we move on to example 8, these get a little bit harder, mostly because it's going to combine information. It's going to combine the stuff that you know that you're just learning how to do with logs with things that you had to do a long time ago, namely quadratics. So here, notice that we've got logs with the same base on one side with subtraction between them. So in order to start this problem, I'm going to combine the logs to become one log. So it's log base 4 of 4x divided by 12 plus square root of x all of that is going to equal 2. Now that I have 1 log on the left equal to 2, I can use the definition of a log, which is 4 raised to that power is going to equal that thing. So 4 squared equals 4x over 12 plus square root of x, which is 16, equals 4x over 12 plus square root of x. Here I'm going to cross multiply to get my x out of the denominator. So I have 16 and then 12 plus square root of x equals 4x. I'm going to divide by 4 on both sides just to simplify. And then I'm also going to distribute. So this 4 gets distributed here and here after I simplified it. So 48 plus 4 root x equals x. At this point, things are not getting easier. I'm going to try and isolate this root as best I can. Because in order to solve for x, I'm going to have to square this in order to get the x out from under the square root. So here's where I'm saying, like, we did all that log stuff at the beginning, and then we got to this place where there are no more logs, but now it's just sort of a nasty equation to solve. So we're just working on solving this nasty equation from all of our previous knowledge. So if I get 4 square root of x equals x minus 48. Now I can square, and I would divide by 4, but that gives me a fraction on the right, so I'm going to square both sides. When I do that, I get 16x equals, now recall this is a binomial, so I have to FOIL it, so it gives me x squared minus 48x minus 48x, which is minus 96x. And then plus 48 times 48, which is 2,304. Then I can subtract the 16x in order to get a quadratic equal to 0. When I do that, I get negative 112x plus 2,304. So at this stage, I have a quadratic. I have to keep solving. So I could try and factor it, but that is hard because it's not factorable. I know that because I tried. And so now, because I have my CAS, I'm going to use my CAS in order to solve it. And in this case, what you're going to do is go to your CAS, and you're actually going to type in the word solve, and then you're going to hit parentheses. And then you're going to type in that equation. So it's going to be x squared minus 112x plus 2304. You're going to say it equals 0 because you can only solve things that have an equal sign in it. And then you have to tell your CAS, what do I want you to solve for? Well, I want you to solve for x. So I put comma x. Maybe. There it is. Now that I have, so it says solve, it gave me, or I typed in the thing. Oops, I left something out, so I'm going to fix that. It should be 112x. Good. Plus 2304 equals 0, solving for x. And now I can hit enter. And it gives me the exact answers. So I would have had to use a quadratic formula. This thing is not factorable. Those are my exact answers. Or I can get the decimal equivalents by hitting the control enter button. Okay, so in this case, we'll just go ahead and we'll write down 27.156 or 84.844. So this is a pretty nasty problem, but mostly it's nasty because it's got roots and you have to use quadratics. It's not nasty because it's a log. Okay, let's look at example B. Again, I've got two natural logs, and I want it to be just one log. They are added, so to write it as one log when you're adding, you use multiplication. So in this case, we would have the natural log of x times x plus 3 equals 1, which is the natural log of x squared plus 3x equals 1. Here we can use the definition of a log, so we know that e, which is the base of a natural log, e to the 1 power would equal this thing. So e to the 1 equals x squared plus 3x. This is another quadratic because of the x squared. So we want to isolate, set it equal to 0 so that we can use the quadratic formula or factor or whatever. So we have x squared plus 3x minus e. Nope, we're not going to factor that. So we're going to go to our CAS. We're going to use our solve feature. That's as far as we can get. So we go to the CAS. You can see I typed in solve, and then I typed in the equation using the little library book option. So control book in order to get e, set it equals 0, and I'm solving for x. When I hit control enter, I get two results. So I get negative 3.729 or 0.729. Negative 3.729 or 0.729. So those are my exact answers. And all of this work that I showed, that's sufficient for me to know that you used your CAS, or you might put something here like CAS solver. That way I would know that you got to this point and then you used your CAS. All right, finally, last example. We're going to start by isolating the log as best you can. So I'm going to divide by 6 on both sides. So log x plus 3 equals 24 divided by 6, which is 4. Remember, log without a base is base 10. So this is 10 to the 4th equals x plus 3. 10 to the 4th is 10,000. And then I'm going to subtract 3. So I get 9,997 equal to x. That one was easy compared to the other two. The only trick was you had to remember that log without a base written down is log base 10. Okay, that's it.